Alright, hi everybody. I'm going to be going through section 9.2 in this video. This is about making inferences about two sample means, and this is going to be for what is called independent samples or non-matched pairs. And when I'm talking about inferences about two sample means, it means we're using two sample means, so two different populations, and we're going to take two samples with their means and standard deviations, and we're going to use that sample data to make inferences about the difference in the two population means. Okay, now this whole thing about independent samples or non-matched pairs, now section 9.2 is about what's called independent samples, and two samples are independent if the sample values from one population are not related to or somehow naturally paired or matched with the sample values with the other population. So what this means is your samples come from, your two separate samples come from two non-related populations. So for instance, I might just be comparing a population of men to a population of women, and there's no relationship or pairing between the men and the women. In section 9.3, we will be doing what is called dependent samples or matched pairs, and this is where the two samples are somehow related. For instance, I might have a sample of men and a sample of women, but they might be men and women that are from, say, a couple, right, a married couple. So the sample of men would be related or dependent on the sample of women. So we'll investigate that in section 9.3. So two samples are dependent or consist of matched pairs if the sample values are somehow matched, where the matching is based on some inherent relationship, like I'm saying, before and after data, two measurements from the same subject, oftentimes like a before and after, or each pair of sample values consist of matched pairs, such as husband-wife data, where the matching is based on some meaningful relationship. Okay, now dependence, just to caution, dependence does not require a direct cause or effect relationship. Okay, so in this section we're talking about independent samples. There's no pairing or relationship between the two samples, or in other words, there's no pairing between the two populations. Okay, now I'll be going back and forth between the handout, which I will post on Canvas with my video and the announcement, and I'll be going back and forth from that handout to the textbook, and rather than there's all sorts of, when we do the hypothesis tests, you have formulas for the test statistic. There's going to be ways of finding degrees of freedom because it will be a t-test, and then there's also a way to use the t-table to get the p-value. For this section, I'm going to do this a little bit differently. I'm actually going to show you how to use statcrunch to enter your sample data. You enter your alternative hypothesis and you enter the sample data, and then statcrunch will actually compute the test statistic and the p-value for you, and then you'll have from that you can use that p-value to compare it to the alpha to know if you reject the null or fail to reject the null. Now I'm just going to go through the book a little bit here. First of all, this is on page 429, as you can see. So there's an example of independent samples at the bottom of the page, and there's an example of dependent samples. So the independent sample is the following heights of samples of men and women, and the two samples are not matched according to some inherent relationship. Okay, so they're just two independent samples that just happen to be listed in a way that might cause us to incorrectly think that they are matched. Also, it's misleading here as well in the independent samples on top. You don't have to have the same sample sizes for independent samples, so I wouldn't have to have the same number of men and the same number of women in each sample. Now, when you look at a dependent sample, maybe I'd have heights of husbands and wives. So since these are husbands and wives, or pairs of couples, there would be a natural pairing between the two samples. In this case, you would have to have the same number of husbands and wives, obviously, since the pairs are matched, or both samples are dependent or matched in some way. Okay. Now, we're going to go through both hypothesis testing and confidence intervals, and again, rather than having you use the formulas by hand to compute test statistics or compute margin of error for confidence intervals, I am just going to show you through example how to take your sample data and use your alternative hypothesis to just plug everything into statcrunch for you so that you can get your p-value. There is an issue with, there are different ways to compute degrees of freedom, and it just gets to be too much to use the formula for degrees of freedom here, as it is kind of complicated since there are technically two different samples. They both have different sample sizes. So first of all, again, there's a hypothesis test to conduct a test of a claim about two independent population means. So just like remember when we did two sample proportions, your hypothesis test or confidence interval is always to, you're trying to find a difference in the population proportions, or in this case, the population means. Okay, so your alternative hypothesis could be in three different forms. mu1 is greater than mu2, mu1 is less than mu2, or mu1 is not equal to mu2. And the confidence interval is used to estimate the difference between the two independent population means. If you read that up top, that's the second objective. Now, notation, you can fill this out in the handout if you have that in front of you. Mu sub 1 is a population mean of the first population. X1 bar is the sample mean of the first sample coming from that first population. Now, it's oftentimes not known, but sigma 1 just a minute, sorry, had a disclaimer pop up. So sigma 1 is down there, it's the population standard deviation. Most of the time that is not going to be known. We're not really interested in that. S sub 1 would be the first sample standard deviation, and N sub 1 would be the size of the first sample. Okay, so everything with a subscript 1 refers to the first population, and the first population or the first sample coming from that first population. And then there's corresponding notations for mu sub 2, sigma sub 2, x sub 2 bar, s sub 2, and n sub 2. So that all those just apply to your second population. Now, there are 4 requirements. Again, there is space to write this down in the handout. So the requirements are the values of sigma 1 and sigma 2 are unknown, and we do not assume that they are equal. Okay, so we don't know what they are. So we don't know the population's means or standard deviations, right? This whole thing is to, first of all, we don't know mu sub 1 or mu sub 2. We're doing a hypothesis test to infer something about the two population means. Okay, but we're not making any inferences about the population standard deviations. We're just going to assume that they're unknown, and we also assume that they are not equal. Or we don't assume that they're equal. Maybe they are, maybe they aren't. Number 2, the two samples have to be independent, meaning that they're not matched. There's no inherent way to match your two samples together, like with before and after data or husband-wife data. Both samples need to be simple random samples. That would be the third requirement. And the fourth requirement, as you can see, now either or both of these conditions need to be satisfied. So the two sample sizes are both large, so they're both sample sizes are greater than 30, or both samples come from populations that are normally distributed. So it's just like the central limit theorem again. So if you have sample sizes smaller than 30 in either sample, then you need to make sure that both samples are coming from populations with normal distributions. Okay, now the formula for the test statistic. Now, if you look at the very top, it says hypothesis test statistic for two means. Real quick, before I go further, I do want to increase the size. There we go. Okay. So the formula for the hypothesis test, or the test statistic formula, you can look down there. So the null hypothesis is just like in the proportions. You would assume that both population means are equal. And the formula for the t-test statistic, which again you're not going to need to calculate by hand, I'm just going to show you how to get statcrunch to do this for you. But the test statistic t, the numerator Okay, you would take x1 bar minus x2 bar, so the first sample mean minus the second sample mean. Mu1 minus mu2 is going to equal 0 because the null hypothesis is that those are equal to each other. And then you would divide that by the square root of s1 squared over n1 plus s2 squared, so the second standard deviation squared over the second sample size n2. And again, you'll see why this would be tedious to do by hand. So first of all, right, you'd have to take your sample data, your two means, your two standard deviations, and your two sample sizes and plug it into the formula for the test statistic. Okay. Now, once you have a test statistic, right, whether you're going to use the t-table or you're going to use statcrunch, you would have to know degrees of freedom. By the way, for some of you might be able to skip forward in the video to see just how to enter all this stuff into statcrunch if you're not interested in all this other information. Okay, so now read about the degrees of freedom. Okay, what does it say? It says, when finding critical values or p-values, it says use the following to determine the number of degrees of freedom denoted by df. So on the one hand, you can do what is called a simple, so the first way is there is what's called a simple and conservative estimate, and the degrees of freedom would be the smaller of each sample size minus 1. So you do each sample size minus 1, and whichever one is smaller, you could use that for degrees of freedom. Okay. Now the issue with that is if you did that and you were doing this on the homework and you were doing everything by hand, that might not lead you to the correct p-value, right? Your test statistic would be fine, but you might get a different p-value. So look at the second note at the bottom. Technologies typically use the more accurate but more difficult estimate given in formula 9.1. So if you look over here, okay, you'd have to actually calculate, right, when you go try to find the p-value in statcrunch or using the t-table by hand, your degrees of freedom would be this quotient a plus b all squared over a squared over n1 minus 1 plus b squared over n2 minus 1, where a is s1 squared over n1 and b is s2 squared over n2. Okay, so again, I've had in the past students compute this by hand, do everything by hand when doing this homework, but I think at this point you guys have plugged enough stuff into formulas, and I think there's no issue with just using the statcrunch has a hypothesis test module or application that you can just get your test statistic and p-value directly from that by just entering the means, the standard deviations, and the sample sizes, and then of course you have to select the correct alternative hypothesis, right, because your p-value depends on whether it's a one-tailed or two-tailed test. Okay, so really, there's not really that much more to this. If you're doing a hypothesis test, you just need to make sure you have the right alternative hypothesis, calculate your test statistic. You'd have to go find this degrees of freedom using this formula I've circled, and then once you have that degrees of freedom, you can either use statcrunch to get the p-value, or you could use the t-table, but like I said, I'm just going to show you how to use statcrunch directly. So let's do an example of a hypothesis test. And then using the same sample data, I'll show you how to use statcrunch to construct a confidence interval. I'll at least write down the basic conclusions to each of those tests. Alright, let's do this. Okay, so like I said, I'm not going to have you do this by hand, but maybe one more time I'll write the formula for the test statistic in here. If you really wanted to do this by hand, the formula for the test statistic would be doing x1 bar minus x2 bar, and you divide it by the square root of s1 squared over n1 plus s2 squared over n2, where x, s, and n are mean, so x bar, s, and n are mean, sample mean, standard deviation, and sample size respectively. Okay, now again, that's not that hard to compute, and it's a little tedious to get your calculator out and plug that in, but the hard part would be, and then you'd have to go calculate the degrees of freedom with that big messy formula. So rather than have you do that, we'll read the next example and I'll show you how to use statcrunch to do the rest. Okay, so here's the example. In a particular school district, suppose we want to compare the mean percentage grade among all students, okay, in Mr. Smith's math classes and Mrs. Jones' math classes. Okay, so I have two different math classes, and I want to compare the mean grade or mean percentage grade among all students in each of those instructors' classes. So for Mr. Smith's class, if 36 of Mr. Smith's students have a mean grade of 78 and a standard deviation of 10, okay, so let me underline that. Or actually, better yet, let me highlight that. It might be better. Okay, so that in yellow, that would be my first sample. So my first population would be, my first population would be all of the students in Mr. Smith's class, and mu sub 1 would be the mean grade of all students. And let me switch colors here. Let me go to maybe blue, like a light blue here. Okay, and then here's my second piece of sample data. Now I have in Mrs. Jones' class, there's 31 students having a mean grade of 85 with a standard deviation of 15. Okay, so a higher mean, but also a higher standard deviation. Okay, perform a hypothesis test to test the claim that Mr. Smith and Mrs. Jones are equally effective teachers with a significance level of 0.10. Okay. Now, here's what we're going to do first. So I'm going to write down all my, actually let me write down the null and alternative hypothesis, and then I'll figure out all my sample statistics. Now, okay, so I need an H0, and I need an H1. And no matter what, right, the null hypothesis is always going to be that the two population means are equal. This is actually the original claim. Right? If they're both equally effective teachers, the mean grade of all their students should be the same. Now, if that's the original claim, the only possibility for the alternative, right, if they are not equally effective teachers, the mean grade in each class would be different. So that's going to be my alternative hypothesis. Now I'm going to write this down on the side before I do the calculation of the test statistic and the p-value. So up in yellow I have highlighted the sample data from Mr. Smith's class, and I have the following information. So I know the first sample size, there were 36 students. I was told the standard deviation was 10, and I was told that x1 bar, the mean grade of those students, was 78. Now that sample of Mrs. Jones' students, there's a sample of size 31. The standard deviation of that second sample is 15, and the mean grade of the sample of Mrs. Jones' students is 85. Okay. Now, from here, all you have to do to get your test statistic and p-value from statcrunch is you have to just recall that sample data right here, and you have to tell statcrunch what the alternative hypothesis is. Okay, so let me kick on over. Let me actually write this down on paper because I might lose this. Okay, you might want to write this down on paper as well before you go over to statcrunch. Okay, now that I have written down my sample statistics and I had noted down what my alternative hypothesis was, I'm keeping in mind that the original claim is actually the null this time. Let's go ahead and go into statcrunch and have statcrunch calculate a test statistic and p-value for us. One thing I want to point out also is that notice that one of the requirements was that either both sample sizes are greater than 30 or both populations are normal. I didn't state anywhere whether or not the students' grades in either of the two Mr. Smith's classes or Mrs. Jones' classes. I didn't state whether those grades were normally distributed, but both sample sizes are greater than 30, so we're good to go. Okay. So what you're going to do now is you're going to go to statcrunch. Hopefully you've written down that information, and you're going to go to stat, and you're going to go to T-stats, and you're going to go to to sample, and you're going to select with summary. Okay, so T-stats, to sample inference with summary, and you're going to open this little applet right here. Now, your first sample, this is coming from the sample of Mr. Smith's class. The mean grade of the students was 78, the standard deviation was 10, and there were 36 students in the sample. In Mrs. Jones' class, there was a mean grade of 85 among the 31 students, and there is a standard deviation of 15. Do not select the pool variances part, and then now what we're going to notice that you can conduct two things. You can conduct a hypothesis test, or you can construct a confidence interval. Now, the null is always that the difference, mu1 equaling mu2 is the same as saying the difference is 0. And then mu1 being different from mu2 is also saying their difference is not equal to 0. Now notice you can choose greater than or less than. Okay? And all you're going to do is hit compute. Okay. Now what I'm doing right now is I'm writing this down. So t is approximately negative 2.21. So make sure you're looking down here. There's your test statistic and there's your p-value. And then notice that the degrees of freedom in this problem actually ended up being 50.959318. Okay. So all you really need to look at though is the test statistic and the p-value down there. Okay, so I wrote those down. I'm going to go back to the handout now. And let me scroll up. Go back to drawing mode. So the test statistic, I ended up getting negative 2. I'll just go to 4 decimal places. I'll just do 2. So I got negative 2.21. And the p-value that StatCrunch gave me, that's approximately 0.0316. And recall that I think the alpha that we're using here is 0.10. I could have also used 0.5 and I would have got the same conclusion. Okay, so the decision, I'll do that first. The decision is, notice the p-value is less than alpha, so we reject H0. So we're actually rejecting the claim that they're equally effective teachers. Okay? We are rejecting the claim that they're equally effective teachers. So the conclusion is there is sufficient, oh my gosh, sorry, that's not going to work. There is sufficient, actually let me write this down first and then I'll start the video again. Okay, so sorry, our decision, our p-value is 0.0316, and with an alpha of 0.10, the p-value is less than alpha, so we reject the null. Since the null hypothesis was the original claim, we can say there is sufficient evidence to warrant rejection of the claim that they are equally effective teachers or instructors. Okay, so that would be our conclusion there. Okay, now with the same data, I'm going to go ahead and show you how to use statcrunch to we're going to construct a 90% confidence interval for the difference in the means mu1 and mu2. The formulas for this are at the top of page 431. So if you want to do a confidence interval to estimate the difference in the two means, mu sub 1 minus mu sub 2, so this would be estimating the difference in the mean grade between Mr. Smith's students and Mrs. Jones' students, so all of the students. Now, the confidence interval estimate would be, what you would do is, just like any other confidence interval, is if I wanted to estimate the difference in the population means, what I would do is I would take the difference in the sample means and I would add and subtract the error to form my confidence interval. And the formula for the error would be T alpha over 2 times the square root of S1 squared over N1 plus S2 squared over N2. And it says the number of degrees of freedom df is as described for hypothesis tests, and it says in this book they're just going to use the degrees of freedom would be the smaller of n1 minus 1 and n2 minus 1. Now, if you check on the homework, you might have to be careful. I'm going to show you how to do the confidence interval using technology, and hopefully that allows for enough accuracy to get you correct on the homework. Otherwise, you might actually have to do this by hand using the smaller of the two degrees of freedoms from each sample. But the formulas are right here. You could start by doing the difference in the sample means from Mr. Smith's class and Mrs. Jones' class. You could use the smaller of the degrees of freedom and the confidence level to find T alpha over 2 and compute the error, and you could do this by hand. I'm going to show you how to do it with statcrunch, and hopefully everybody can let me know in class if they're having any issues. I can certainly make another video showing you how to do it by hand. Okay, so I'm going to use that same information as before, and my confidence level is going to be 90%. And I'll go ahead and show you how to use statcrunch for that. It's actually pretty simple. It's in the same place that you did the hypothesis test. Okay. So back to statcrunch. What you can do is go back to stat, tstats, to sample with summary, and you can enter all that information in again. So the first sample mean, Mr. Smith's class had a mean grade of 78. Standard deviation of 10, and there were 36 students in the sample. And the mean from Mrs. Jones' class, the mean grade was 85, the standard deviation was 15, and the sample size was 31. Now what you're going to do is you're going to come down here and this time select confidence interval, and our level, since it was 90%, our level is going to be 0.90. And what I'm going to do is I'm going to hit compute. And if you look on the right, you will notice a lower limit for your confidence interval and an upper limit for your confidence interval. Okay. So I'll write that down on my page. Okay, and I'll go back to the handout and I will write that down in the forms that I would typically like people to write down. Okay, so now, what's my 90% confidence interval? What I can write is, there's a couple for the confidence interval itself, there's two ways of writing this. You can write the interval, and I'll just round this to, I don't know, 2 decimal places, minus 1 point, actually hold on, sorry, it's the other way around. It was minus 12.31 for the lower level and minus 1.69 for the upper level, or I like it better if it's written this way. And remember, mu sub 1 is from Mr. Smith's class. Let me rewrite that. That looked... And mu sub 2 is from Mrs. Jones' class. So what this is really saying is, if you took Mr. Smith's class and subtracted we're estimating that if you took the mean grade for all students in Mr. Smith's classes and subtracted the mean grade for all students in Mrs. Jones' class, we estimate that that difference would be between negative 12.31 and negative 1.69. Notice this confidence interval does not contain 0. Both your limits are negative. And what this means is we've basically just estimated that with 90% confidence that the mean grade in Mrs. Jones' class is higher than in Mr. Smith's class. And of course, what I could say here, I can write this down for everybody. The conclusion that you would want to write here is, let me write that a little easier. We are 90% confident that the difference mu1 minus mu2 is between negative 12.31. I'll write the difference in means is between negative 12.31 and negative 1.69. And I guess if you want to think about it this way, since the difference between Mr. Smith's mean and Mrs. Jones' mean, since we estimated that to be negative, we could say that, Mrs. Jones, right, we know they're not equally effective instructors, just like the conclusion of the hypothesis test, but Mrs. Jones is a more effective. I'm going to run out of room. I got to rewrite that, sorry. Mrs. Jones is a more effective teacher. Okay, so for those of you doing this, trying to get extra credit, hopefully using the calculator on statcrunch leads to the correct confidence intervals. If anyone's having an issue, please let me know. Thanks for tuning in, and hopefully this helps you get through that homework. I hope everybody has a good day. Bye.